And now we're going to talk about security and secure content and being able to crawl and serve secure content with the GSA. In the past, we've already set up the initial network configuration on the search appliance. It's configured in our network. We've set up crawling for public content off of web servers, and we've set up serving of the content using different user experiences for different user groups with front ends. And we've turned on some of the basic features. Now what we want to do is investigate how to set up secure content and how to get the content into the GSA, and then how to serve those results to the users so that only the users with permissions to the documents get those documents. We're going to describe a couple of processes here to understand security. The first thing to understand is the concept of authentication and authorization. We'll describe the differences. Those are different steps that occur. The search appliance is going to have to authenticate users to check to see they are who they say they are, and then it's going to have to authorize each individual result so that users only get access to the documents they have permissions on. We'll show how security works with the search appliance. As we'll see with security, users have to authenticate and then get authorized to documents, but now we have to add an extra step in there. The search appliance has to crawl the content first, index it, mark it as secure, and then the users can get access to it with authentication and authorization. We're going to configure some basic protocols. There are a number of protocols such as HTTP Basic, NTLM, Kerberos, LDAP, SSO with cookies, X.509 client certificates. So each of these different protocols has different functioning and operation. We'd have to explain each one as we go through it. And the search appliance has a different way of configuring each of these protocols. In this example, we're going to focus on what we call the HTTP-based protocols, which are HTTP Basic, NTLM, and LDAP. They're very simple, lightweight protocols. They're based on a user ID and a password, and there's probably going to be a prompt involved. As we'll see, sometimes authentication can occur silently. That means the user's credentials can be checked without the user even knowing it. Now, to give us an overview, enterprise content management systems, file systems, SharePoint, databases, private applications, a lot of these have secure content behind them. And in order to protect this content, the system has to first check to see if the user is who they say they are. That's the authentication phase. The user is going to have to present something that they know or something that they have. Typically, if it's something they know, it's a password. If it's something they have, it's usually a certificate or a token, some kind of encrypted piece of information stored on their workstation or in their browser. They may not even be aware of this. Then, when they want to make requests to a server to get individual documents, each one of those the permissions for that user has to be checked on each of those documents before they can be served. So this is an example here of a HTTP Basic prompt that we'll often see with a HTTP Basic on say a web server like an Apache or an IIS server. What does this process look like of securing content? In this diagram, we see there's an LDAP server where the user's credentials, their usernames and passwords, are stored. We'll see a content server here where authorization occurs. This server has the list of documents and which users have permissions to them. When a user makes a search request, that request is sent to this is a content server. There's no search appliance in this diagram. The content server then is configured with the LDAP server to perform authentication, or it could have the user IDs and passwords stored locally. Okay, so it could be that the user credentials are here or here. The user will be challenged with a prompt to their browser, and then the user responds with the user ID and password, or silently with some type of a credential that's hidden, and that's checked against wherever the user identities are stored in LDAP or on the content server. Then the response goes back, and often there's a session cookie or some type of a session cookie or some type of session information stored in the user's browser so that when they return to that site, they don't have to enter their credentials again. They can simply be checked for the server knows who this user is because there's a secret encrypted piece of information sent back with the next request, and the user has a session on that content server, so now they can just check the session information to see who they are, and then they'll check authorization. What does this look like with an example? Let's take our Apache web server, and we have some directories that are publicly available to content and some that are restricted. Right here we could click on any one of these directories, and we would see the documents in that directory, and the permissions have been, there's no permissioning set up on the content server, so there's no need to check for credentials. But there's also there's a directory that's secured with what we call HTTP basic protocol. And when a user tries to go to that directory, the web administrator has said this is a secure directory. Only users with proper user ID and passwords can come to this directory. So now I have to authenticate. This is an HTTP basic prompt that the server told the browser to prompt this. The user has to enter in a user ID and password, and they can get access to the content. Now what's happened on the browser side, in the history of this browser, the credentials are stored, and anytime a user goes to make another request for, say, a document, they don't have to present these credentials. The browser just passes that user ID and password along with the request, and if the user is authorized to that content, they will get the content. If I were to clear the history and try to access the document, this removes the user's ID and password from the browser. When the user tries to click on the content, they'll have to be reprompted. Now that's how HTTP basic works on an Apache web server without the GSA. Now let's take a look at how security works with the search appliance. And in this example, we're going to continue to keep it simple. There was no LDAP server set up. The credentials were stored locally on this content server. So authentication and authorization takes place locally. We're going to continue. We'll look at the example with the search appliance, and the user sends a request for search results, and if it's a search for just public documents, the search appliance returns public results only. Doesn't even look in the secure portion of the index. If the user runs a request for secure content, then the search appliance first checks to see, has this user authenticated? Have I seen proof that they are who they say they are? And if they have not presented the credentials, a challenge will be sent to the browser. And this can come in the form, it can be a prompt, or it can be silent. Once the credentials are gathered, the search appliance then authenticates the user, checks the credentials with a back-end server. It could be an LDAP server or a content server. Here's the LDAP connection. Here's the content server. In this case, the first example, we're not going to set up the LDAP server. We're just going to rely on the content server to provide authentication and authorization. So the way that this will happen, we'll configure in the search appliance a sample URL that every user in this system has read permissions on, and we'll tell the search appliance to send a GET request over to that sample URL, and if the user comes back with a 200 response from the web server, that indicates that the user's credentials were valid. We'll then say that the user's authenticated. We'll save some session information in the GSA and create a session cookie that identifies this user, and we'll send that cookie back with the search results. We will check the index for everything that's marked secure here. So you can see document 2 is marked secure, document 3 is marked secure. We'll send HTTP head requests for authorization. At this point, authentication is complete. What we're going to do now is we're going to check for each of the, we'll build up a list of search results, potential search results for a user, and maybe it's documents 1, 2, and 3 in this case. 1 is public, so we'll return 1. 2, it's secure, so we'll send an authorization check in the form of an HTTP head request. We just want to send out a GET request to this backend content server for document number 2. And we'll pass the user's username and or the authentication information that was used. So either it's a user ID and password, or it's some type of if there's a session cookie that's set up with the content server in the backend, we'll send the session cookie. In the case of HTTP Basic, we'll just make a head request and pass the user ID and password. If the user has permission, they'll get access to document 2. The search appliance will get a 200 OK response, and then include document 2 in the search results. If document 3, however, they do not have permission to it, they'll get a 401 authorization required. Then the search appliance will remove document 3 from the search results. So the user only sees document 1 and 2. To close out this session, they get their search results and they get a session cookie with the GSA. Now when the user runs subsequent search requests over to the search appliance, the session cookie identifies the user. We don't have to go through authentication. We'll just go through the back-end authorization phase. So let's see what we have to do to set this up. The search appliance, we said, has to crawl the content that's secure first. So we'll have to set up something called crawler credentials for HTTP Basic. And what we do is we identify the URL pattern that's protected by HTTP Basic and give it a super user or an interface user account that has read permissions on all the content. Search appliance will then, every time it tries to fetch this content, it will use these credentials to crawl the content. When it comes time to serve the content, we'll set up on the authentication mechanisms page, there's a tab called HTTP base protocols, and we'll identify a sample URL and give it a mechanism name and set a timeout. This will be used, the search appliance will use the sample URL to authenticate the user at search time. So this is the crawler setup, this is the serve setup. Before I set up the crawl patterns, I need to set up crawler access. This gives credentials to the search appliance to use for the crawling. I'm going to set up a user that has read permissions on all the content. It just so happens that this is going to be the same user I use in my search, but it could be somebody different. It would typically be somebody different. I'll save the credentials, so every time the search appliance tries to fetch a content in this URL pattern, it will send these user credentials at crawl time. Go back to set up the crawl URLs. Start pattern and the follow and crawl. And I'll wait for some time for that to complete the crawling phase. Now I've got another server that's already set up and it's already crawled the content. When I go to, I can run a real-time diagnostics check. This will check my fetching phase for content in this directory. Here's the 401 authorization required challenge. And here's the 200 response OK because the crawler credentials were used. To set up the serving so that the user can be authenticated at serve time, I will go to Universal Login Authentication Mechanisms. Since I'm only using one credential, one set of credentials on one server, I'm just going to use what we call the default credential group. If you had multiple credentials, you'd have to set up multiple groups. Under HTTP basic methods, let's delete this. I'll show how to add this real quick. It's already been set up, so I'd enter in a name for the mechanism, which can be anything. It's just administrative purposes, and I'll give the sample URL that every user has read permissions on. So that's this restricted 1-HTML. I'll say save. Now this rule's been defined. When users come to the search appliance, run a search, the search appliance will look and see this rule applies. There's secure content. When the user wants to run a secure search, I have to authenticate the user, so I will throw up a prompt. The user will have to enter in their password and username. Now let's go back to our browser, And on GSA 13, it's time to run a secure search. We'll first run a public search and see what happens. If I run a search for salmon, the user was searching for content that was secure, but they had not made this a public and secure search. So the search appliance only checks for public, content in the public portion of the index, and there was no content. If we go to the cookies, notice that the search appliance has set up 3 standard cookies that do not represent the user as a logged in session. I'm going to leave these cookies alone. And now we'll run a public and secure search. Search appliance now knows that the user wants to look into the secure portion of the index. There was an HTTP-based the setup in here indicates that the user needs to be challenged for credentials. So the user gets displayed not the pop-up that we saw before, but now we get a single sign-on form from the search appliance using something called the Security Manager. So there was a redirect to a web page on the GSA. Enter in username and password. The search appliance will send these credentials to the sample URL, and if the user succeeds in getting access to the document, then the user is authenticated. And the search appliance will then move on to the authorization phase and look for documents that match this search criteria salmon that are not only public but also secure. Here's the secure document. The user will only see results that they have permissions for. We don't have a set of documents to show you right now. If there were documents in the web server that were secured but the user did not have permissions on them, they would not see these documents right now. Let's look at the cookies first. Notice that a session cookie has been added for the search appliance. This means this is the session cookie that identifies this user for subsequent search requests. Every time the user runs another search request, they don't have to be authenticated with a prompt anymore. They'll just pass a session cookie. The GSA opens the session cookie, finds the user's finds an encrypted string that identifies the user session, looks inside the session on the GSA, extracts the user's name, and says, ah, this is HTTP user. So now I know who this is. I don't have to re-authenticate the person. I'll just check authorization. So if I run another search for, say, in URL restricted, I get more than that. I get documents that are still restricted. I didn't have to go through the authentication phase. I just went through the authorization phase. Now, if you click on what happens when a user clicks on a link, this sends a GET request back to that content server on the Apache web server. And let's clear the history. We've already logged into the Apache web server, so I have to clear the history so that you can see what the user experience will look like when they first come to when they first run a search. They may be challenged for credentials on the back-end Apache web server. So this doesn't necessarily create for the best user experience. We had to log into the GSA and we have to log into the Apache web server. So what we can do is switch protocols to a protocol that's silent. HTTP Basic and LDAP are not silent, so they're going to continue to present this kind of challenge. Let's take a look inside of our search appliance and see what kind of information we can gather or glean from the interactions that occurred behind the scenes. To do this, especially for troubleshooting, we can go to Universal Login. And here we can download something called the Security Manager log. When I open this up, at the bottom of the file, we'll see the most recent activity. And what we're looking for, we'll have to scroll up here. It's going to give you a lot of information. Here was a successful login authentication Here's authenticating, and it was a successful authentication. Who was the user ID that we obtained? The credential was verified. The user was HTTP user. So this is a way of checking to see the authentication phase occurred properly. If you're not seeing search results here, we got past the, if we didn't successfully log in, we may have seen the prompt reappear. Let's see what that looks like. So I'll clear the session cookies. To start a new session with the GSA, I have to clear the session cookies. That includes my GSA session ID, this one down here. It looks like it cleared it. I'll just do a second clear just in case. We'll go back to run another secure search. Now, if I've cleared the authentication, the session cookie properly, I will be reprompted by the search appliance when I run another search. In this case, that's what I want to do because I want to do a little bit of troubleshooting. Now, if I'd entered in a user that didn't have permission on the sample URL, remember this was a different user entirely, then I would be reprompted. What we'll see here is on the search appliance, the default behavior on this is the security manager. The default behavior is on 3 unsuccessful attempts, we will assume that authentication failed, and we'll simply move on to the presentation of whatever results that user has access to. In this case, the user's has not been authenticated, so they don't have access to documents, and they don't see the results. If I go back to the administration console, download the security manager log again, and open it, I'll see this time authentication was unsuccessful. And what was the user's name? Authenticating failure. Verification failed. And here was the user ID. Now we know the user ID, the user ID here is helpful for us to identify which session we're talking about. It may be that there's a lot of users on the system. You may be doing a lot of testing, or it may be in a live production system. You want to find out which user it is. This is one of the ways of isolating the user's session. You can also see here's the session ID that's used to track this. So up here we had earlier an ID right here. So let's go back down to the, in this case, student. And here was the session ID. This session ID will be different than when I tried to log into using the HTTP user. Here's the successful request. Here's the session ID, and the session ID is different for the HTTP user. So this is a way to track through the logs, looking for the session ID, the user's name, and then seeing whether the authentication was successful or failed. In addition to the security manager logs for authentication, we can also look at authorization logs under access control. Authorization logs, and we can, let's see, I'll have to show this in Finder. It's a zip file. Authorization logs can get quite big. And again, this is the latest information will be at the bottom. Here's the verified user ID HTTP user, and there was a, here's the session ID, and the decision was permit by head request. So here's in our diagram, back here, these are the head requests that are being sent out for authorization for each individual document, checking the user's permission. And here's the URL that was being checked. Now, once a head request comes back with a response for a user, we store that response in something called the Auth-Z cache on the search appliance. We don't show it here, but there's a separate cache down here that stores results for up to an hour, for potentially up to 10,000 user requests for individual documents. User 1 runs a search for 10 documents that are secure, then 10 results come back. We store those 10 results in the Auth-Z cache because a lot of times users run subsequent searches for similar documents that return the same documents. So it doesn't make sense to send a lot of head requests back out to the content server. Also think in terms of what this does to performance. If we send out if we run a search request for let's say salmon, and salmon returns 50 different results that are relevant, we have to potentially check how many documents do we have to potentially check. Well, we first have to send one page worth of requests because we're going to build up just one search page. It might be 10 results or 15 results. So we'll send out those 10 head requests out to the backend content server. We can do this in parallel, and web servers are designed for a lot of parallel processing, and so is the GSA. So we can do a lot of this as parallel process requests. We come back with 10 results. If the user has a high deny rate and doesn't get access to any of those documents, we still have to build up a page worth of results, and we haven't gotten our 10 results yet. So we'll send out another batch of 10 or more head requests and get those results. If those all return back deny, we have to continue on. So there may be a lot of back and forth traffic going on between the search appliance and the content server for authorization checks. Caching the Auth-Z results on the GSA will help with this performance, but it won't solve all the performance problems. And this problem gets even more exacerbated when we deal with something like dynamic navigation, where we have to maybe collect up to 8,000 results just to build up the categories on the left hand, just on the navigation groups. To help with this, we can move to a faster form of authorization called ACLs, Access Control Lists. ACLs can be inserted into the search appliance at crawl time using a feed, or you can go into Administration Console and add policy ACLs for groups of documents based on URL patterns. Let's see what this looks like. We're not going to go into this in this section, but I want you to be aware of it. Under here, you can specify a particular pattern, create a new policy ACL, and give certain users permission. And you can add all the different users. You can also add groups. We'll have to be concerned about where the user groups are coming from, and that opens up another topic under ACLs. Under the access control page, there's also settings controlling the Auth-Z cache. So how long are the Auth-Z requests kept for? How large is that cache? Here's the duration. And you can clear this cache. Let's go back to the Auth-Z log and look here. Notice that it was added, the permission was added to the cache in the GSA. So the next time we run a check for authorization, this was the second search request, the permit is by cache, not by head request. If you're troubleshooting, you may need to clear this cache out. Let's say we've tested some search requests on content on a web server. User has access to document 2, and then something like a permission changes on that document. This is not only for development, but this is also for production. If the permission on document 2 changes on the web server, the user no longer has permission to it, well, for up to an hour, this user may still get permissions granted by the search appliance, because the search appliance will look at first, it will look at the cache, the auth-z cache on its inside of its index. To change this behavior, to stop this from happening, you can come in here and set a shorter duration for the cache, right here, or you can clear the cache manually. I'm going to clear the cache, and now if I were to run a subsequent search request, the GSA would see that there's nothing in the auth-z cache for document 2 stored, so we will have to send a head request back out for the content server. Now that gets us through quite a bit of information for security. What I'd like to do now is return to our section and consider what happens in this case where an LDAP server contains the credentials. Not the content server. It does not maintain the user's ID and password. It maintains authorization permissions for specific users and documents, but the username and password is up in an LDAP server. We can configure the search appliance to check the credentials off of the LDAP server and then send head requests over to each document at search time for authorization. To do this, we go to a different configuration page on the search appliance. We go under Administration, LDAP Setup, and we provide the host name, port, and a user that can bind itself to the LDAP and make requests to the LDAP server for user authentications. We'll add a test user to test connectivity to the LDAP server and make sure that the host can be found, the port is listening, that the bind user credentials work, and that we're able to look up this user in the proper location in the LDAP server. Then under the security authentication mechanisms, we'll go to the LDAP tab and identify that we want to use LDAP for authentication and also possibly look up the group information inside of here. On this search appliance, we've set up an LDAP. We've set it up, crawled the content. Let's set up the LDAP. We go to LDAP Setup. AD1 is my host. Port 389 is my listening port. Here is my user that I can bind with and perform lookups. I'll enter a test user. The test was successful, so I'll save my LDAP settings. One more thing. Status serving, here we go. Auth mechanisms. Scroll over to the LDAP tab. Check the boxes for authentication and group lookup. Give it a mechanism name. Now I can navigate over to GSA 15. Now if I run a search for secure results using a user on the LDAP system that does not have permission to the documents, authentication will succeed, but authorization will fail. And so I did not get access to the documents inside of the restricted directory. Now this concludes our investigation of security on the search appliance. There are other types of security protocols that we'll look into in other modules, including forms-based cookies, typically with an SSO system. This is where the back-end content servers use cookies, not just the GSA. We'll look at Kerberos, which is a highly secure protocol for Windows and Unix servers. We'll look at, it's very common commonly used in SharePoint. We'll look at SAML, which is the Secure Access Markup Language. If you have a proprietary security system that we don't support, you can always build your own SAML provider or add a plugin for SAML to your content server, and the search appliance will send SAML messages back and forth to that provider. SAML is standards-based. It's using SOAP over XML. And it's just up to you to have that plug-in or build your provider that adheres to the protocol, and then SAML will be, the GSA will be able to talk to your provider. X.509 certificates is another topic, but we don't go into that. For more information, see the documentation. So in this, to summarize, we've talked about security. There has to be crawl set up for for accessing the secure content. There has to be serve time security for authentication, and the authorization checks will occur. We've seen how security works with the search appliance. We looked at HTTP Basic and LDAP. The NTLM setup is very similar. All it is a checkbox on the authentication tab. So for more information, look in the documentation or check our other training modules. Thank you.